we started out with 37 teams in this year's competition and have now whittled it down to the best 6. And these teams are going to convince you that they are the next big thing in photonics. Please help me welcome Marina Madrid, the Chief Scientific Officer for Cellino.
Thank you. My name is Marina. I'm the Chief Scientific Officer at Cellino, and we are using lasers and nanofabricated substrates to enable gene therapies. Last year, in the US alone, 172,000 people were diagnosed with one of 3 types of blood cancer. With the currently available therapies, half of them would die within the next 5 years. But it doesn't have to be that way. We know what a cure would look like. You could take a patient, extract their blood cells, treat them by delivering therapeutic cargo, such as a gene editing tool, into their cells, put them back into the patient, and they would be cured. It's entirely possible. The tricky part is the delivery. In order for this to work, you need a safe, efficient, reliable delivery method. And scientists have been working on this for a while. There are delivery methods out there. We, as a society, have invested more than $1 billion in trying to develop the ideal delivery method. And still, none of the currently available delivery methods are safe enough, efficient enough to be used reliably in treatments. Our delivery technique is quantifiably better than the best available delivery method. We have no toxicity risk. We are cost effective compared to viral-based delivery. We can deliver a wide range of cargoes to a wide range of cell types, unlike liposuction. We don't leave any metallic residue within the cells, unlike nanoparticles. And when it comes to blood cells, our viabilities are 37% higher than the most popular physical-based poration method. We use laser-activated, nanofabricated substrates to porate the cells. Delivery cargo, such as a gene editing tool, can enter the cells through these pores. We hold 3 patents filed with Harvard University for this technology, and we have multiple peer-reviewed publications. This is a design of our device. It's very compact, a benchtop device, easy to install, easy to operate. You simply take your cells, you take your nanofabricated substrate, you put it into the device, you push a button, and it outputs treated cells. You can imagine it like an espresso machine. The device itself is the coffee maker. The nanofabricated substrates are the coffee pods. We envision ourselves selling this device through 3 channels. In the initial stages, we're going to market our device to gene editing companies and research labs. And this one has one huge advantage compared to other medical devices, is we don't need to obtain FDA approval on our own. The gene editing companies will work to obtain FDA approval for us. After that has happened, we will work with gene editing companies to market our device to hospitals and doctors to be used to treat their patients. And there's a massive market for this. These are projected estimates for 2020, and the total gene therapies market is estimated to be between $11 and $42 billion. Of that, $2 billion is estimated to be devoted to delivery methods alone. We plan to enter this market by spending this first year prototyping our device. Over the next 2 years, we will work with gene editing companies to customize our device for their therapy. And that's one of the really beautiful things about our technology. It's incredibly versatile, can be used for any disease that affects the blood. Then we will spend 5 years assisting these companies during the FDA approval process, after which we will work with these companies to sell their therapy and our device to hospitals and doctors. This is our core team. My name is Marina Madrid. I'm the Chief Scientific Officer. I'm in the PhD program in Applied Physics at Harvard, and I'm an expert on nanofabrication. This is Nabia Saklayan. She's also here today. She's our CEO. She's in the PhD program in physics at Harvard, and she's an expert on laser optics, particularly for the use of cellular therapy. This is Jacob Florkovich. He's also here with us today. He's our Chief Business Officer. He's in the MBA program at Harvard, and he's a former McKinsey consultant and has experience commercializing technologies. We are extremely lucky because we work well together, we're a diverse team, but we also have a good balance of scientific and business expertise. And we are backed by an advisory board who are world-leading experts in their fields. Eric Mazur is a professor at Harvard, expert in the use of lasers for cellular therapy, and has already successfully founded a startup based on laser-based technologies. David Skadden is an expert in the use of stem cells for regenerative medicine. He's the director of the Harvard Stem Cell Institute, and he recently founded Magenta, a gene editing company that raised more than $50 million in funding. Ali Rabi is an MD PhD at Harvard Medical School. and Massachusetts General Hospital, and he's an expert in viral diseases that affect the blood. We are Cellino. We are genuinely excited because we really believe that our technology has the potential to change how we treat blood diseases. I hope we've convinced you too. We're a young startup. This prize would go a long way in building our first prototype, so please feel free to ask me any questions you might have. We're all going to be around after the competition as well. Thank you.
And now first place, receiving $10,000, goes to Cellino. All right, let's give a big round of applause for all the participants.